Hello and welcome to the BMC Quick Course Series. My name is Bob Albrecht and I am a BMC IMS software consultant. In this session I will introduce and overview the FastPath Analyzer EP DEDB analysis tool and functions. This function lets you analyze and validate the content and structure of DEDBs and lets you generate a variety of useful analysis reports. FastPath Analyzer EP analysis function gathers the data required for assessing DEDB capacity and performance characteristics. FastPath Analyzer EP does more than just validate pointers. You can examine and validate pointer data during every analysis run. In a single run, you can analyze one or more areas and see the information in a report. You can set thresholds to detect exceptions, and the statistics repository stores information that you can use for historical reporting. You can extract information as input to the area change modeling utility. This utility lets you model a potential DEDB change before implementing it. If discrepancies are found during validation, use the control interval dump and modification utility to dump the CIs involved so you can locate the segments in error and determine the proper values for them. Then you can make and commit the changes required to fix the errors. The analysis function validates the structure of the area, that is, the physical and logical integrity of the area, to ensure that the area can be read and interpreted correctly. It validates that the CIs are of the proper type and are in the proper sequence. It also validates the IMS overhead bytes in the CI prefix and the VSAM overhead bytes in the CI suffix. The free space element chains that each wrap, DOVF, IOVF, and S-step CI is filled completely with segments, FSCs, and scraps, the allocation table entry in the space map, and the free block chain within the dependent overflow, and it cross-validates each IOVF CI with the corresponding entry in the space map CIs. The analysis feature checks that each pointer to a root or direct dependent segment references a location within the direct portion of the area. The physical child last and subset pointers are null if the corresponding physical child first pointer is null. That the physical child last pointer is not null if the corresponding physical child first pointer is not null. That each pointer to a sequential dependent segment references a location within the sequential portion of the area, and that the complete 8-byte pointer references a position within the valid logical bounds of the sequential dependent portion of the area. The analysis function validates the logical integrity of pointers to the root and direct dependent segments. Logical verification is the process of validating that the pointer chains among segment types are correct. It checks every pointer to ensure that a segment of the proper type actually appears at the referenced relative byte address. That every segment is referenced by one and only one physical child first or physical twin forward pointer. Physical child last and subset pointers to verify that the segments that are referenced appear in the chain that is defined by the pointers. All keyed segments for correct key sequencing to ensure that the sequence keys of logically adjacent segments are ascending and unique. Logical verification identifies the complete chain of dependent segment occurrences associated with their parent segment. The analysis function can produce reports that contain detailed data about database performance, space usage, segment characteristics, and record characteristics. The Area Summary report provides basic information about each area analyzed. It is generated automatically with each report set. Space usage reports include free space, IOVF space, and UOW detailed analysis reports. Segment reports include pointer, segment I/O, segment length, and segment placement analysis reports. Record reports include record length, record placement, record profile, and synonym chain analysis reports. Here's an example of the information contained in the Area Summary report. You can see that it contains summary information regarding the root addressable area, independent overflow, and the sequential dependent or S-step portion of the area. The fragmentation factor within the performance factors portion of the report represents the level of fragmentation or disorganization in the area based on free space elements and out-of-block pointers. Threshold exception conditions, if any, are shown on this report as well. You can use the threshold subcommand to monitor particular database characteristics. Exceptions can be detected for free space, excessive I/O, wrap usage, and degree of use of overflow. All exceptions are included in the area summary report. The statistics repository is an optional facility that stores statistics gathered during analysis. You can retrieve the statistics for reporting and subsequent processing. Each time an area is analyzed, a statistics record is appended to a user-specified file. We recommend that you use the statistics repository. The repository consists of a single catalog dataset called the repository catalog and a number of statistics datasets. Statistics datasets are sequential files that contain the detailed statistical information. You can retrieve and print historical reports from the repository for monitoring and analysis. You can generate a file that contains historical summary records and use this file as input to a user-supplied reporting facility for trend analysis and planning purposes. This concludes the introduction and overview of FastPath Analyzer EP. Thank you for your time. For more information on any BMC mainframe product, please visit the URL shown here.